Welcome to Chem Help ASAP. Let's examine the output file for ethylene and introduce a new idea called Huckel theory. Here is the structure of ethylene, or ethene. The key feature of ethylene is the CC-pi bond. If you have learned much about bonding, you likely remember that the CC-pi bond on the far upper right is created by addition of adjacent p-orbital wave functions, psi, on the carbons. These two p-orbitals also overlap through subtraction to form an antibonding orbital, the pi star to the lower right. We tend to focus on the bonding orbital because that orbital is filled with electrons. The pi star is a vacant orbital. Notice that the pi star is drawn with a node between the p-orbitals. Okay, that's enough review. When you talk about pi bonds, the p-orbitals are perpendicular to the framework of the molecule, the sigma bond framework. Because the sigma bonds are perpendicular to the pi bond, there is no overlap between the pi bond and sigma bonds. We can treat the pi bond independently of the sigma bonds. This makes working with pi bonds much easier, and this simplification is called, in the upper right, Huckel theory. The same Huckel who came up with Huckel's rules for aromaticity. Let's see how this simplification appears in the output file for ethylene. Here is our output file. Ethylene has 12 valence atomic orbitals. So the output has 12 molecular orbitals. Ethylene has 12 electrons. Those electrons fill 6 orbitals. MO6 is the HOMO, the highest occupied molecular orbital, and MO7 is the LUMO, the lowest unoccupied molecular orbital. Let's see these two orbitals. There's something interesting. All the coefficients in MO6 and MO7 are 0 except for the px orbitals on carbon 1 and carbon 2. Those coefficients show that, according to this output file, there is no overlap, no interaction between the other orbitals in the molecule and these two px orbitals as they form MO6 and 7. These are the pi bonds. Look to the far right. We have the pi bond, MO6, and the pi star, MO7. According to the output file, these orbitals are identical except for the mathematical sign changes for one p orbital in MO7. In MO7, the p orbitals are flipped relative to each other, and that creates a node between them. If the signs are the same, it's a bonding interaction. Opposite signs give an antibonding interaction. We've only scratched the surface of the implications of the Huckel method on MO theory. On small molecules, the Huckel method approximation works very well and greatly simplifies predicting pi bonding and antibonding orbitals.